Alright, so today I'm going to show you a video just to review on how we can multiply decimals by decimals, okay? And it's pretty simple. We've talked about this before, but in case you forget, this is a good review video to watch. So we got two different strategies. Strategy one is my personal favorite one, especially if we have a whole number and then a decimal after that. So 6 and 8/10, for example, times 2 and 1/10. The first thing we want to do is we just want to make an estimate, and we want to make the estimate simple and easy. So 6 and 8/10, okay, that's about 7 times 2 and 1/10, that's about 2. So 7 times 2 equals 14. That's just a quick, easy estimate for me. If you wanted to make that 10 times 2 and get 20, that's fine too. As long as you're not off by a whole lot, it's just to help us place the decimal. So step 1, did that complete. So 7 times 2 equals 14. Step 2, I'll do step 2 in red here. Step 2 is to multiply as if the factors were whole numbers. So I'm going to pretend that there's no decimal here and just multiply these factors as if they were whole numbers. So I'm going to do 68 times 21. So I'm going to ignore the decimal. So if I ignore the decimal, I end up with 68 and then times 21. I'm going to do that down here. And then it just multiplies if they're whole numbers. And we know how to multiply multi-digit numbers. 1 times 8 is 8. 1 times 6 is 6. I'm going to append my 0 to the 1s, and I'll start multiplying my tens digit. 2 times 8 is 16. Regroup my 1 over here. 2 times 6 is 12, plus 1 is 13. And now I add them up. 8 plus 0 is 8. 6 plus 6 is 12. 3 plus 1 is 4. And 1 plus nothing is 1. And now the last thing I need to do, now remember we weren't really multiplying 68 times 21. We're really multiplying 6 and 8/10 times 2 and 1/10. So now I use my estimate to help me place my decimal. So I know my answer should be around 14. So here would be my tens, my ones, and the decimal always goes behind your ones place. So my answer is 14 and 28/100. So 6 and 8/10 times 2 and 1/10 equals 14 and 28/100. Okay? That's how it goes. We'll do another example. So now I have 34 and 2/10 times 0 and 67/100. Again, step 1. Step 1, make an estimate. So I'm going to say 34 and 2/10. I'm going to make it easy. That's close to 30. Times 0 and 67/100. I could do 1. Sure, 30 times 1 is 30. Or some of you might think, okay, 34 and 2/10 is close to 30. 0 and 67/100 is close to half, or 0 and 5/10. So half of 30, or 30 times 0 and 5/10 is 15. Okay? Both are fine estimates. They're just going to help us know where to place the decimal point. So step 2. I'm going to do step 2 in red. Step 2 is to multiply as if the factors were whole numbers. So I'm going to pretend that decimal's not there. So then I'm going to end up with 342 times 67. I'm just going to ignore the decimal point. And here I don't have any ones or tens or hundreds, so I have nothing to the left of my decimal point, so I'm not going to include that 0, so it's just 67. So now I'm going to multiply. 7 times 2 is 14. 7 times 4 is 28, plus 1 is 29. Regroup my 2 over here. 7 times 3 is 21, plus 2 is 23. I'm going to cross out everything that I used to borrow. Append 0 here. 6 times 2 is 12. 6 times 4 is 24, plus 1 is 25. 6 times 3 is 18, plus 2 is 20. And now I'm going to add them up. 4 plus 0 is 4. 9 plus 2 is 7. 5 plus 3 is 8. 2 plus 0 is 2. 2 plus nothing over here is 2. And now here's my product. Now remember, I wasn't really multiplying 342 times 67. I was really multiplying 34 and 2/10 times 0 and 67/100. So I'm going to look back at my estimate. I had 30 for my estimate here, and I have 15 for my estimate here. Well, based off of my estimate, I know my decimal point should go, the only place where it makes sense should be here. 22 and 874 thousandths. If I put my decimal here, that would only be 2 wholes, and that's not really close to 30 or 15. If I put it back behind my 8, that'd be 228, and that's definitely not close to 30 or 15. So the only place that makes sense is right behind my second 2 here. So that's my tens, my ones, tenths, hundredths, thousandths. 22 and 874 thousandths is my answer. Now, what happens if we have a problem like this? And this is where strategy 2 can be helpful, okay? So now I have 0 and 37 thousandths times 0 and 78 hundredths. One way to do this is to certainly make them fractions, okay? So I could multiply 37 1,000ths times 78 100ths, and that would equal, well, I would do 37 times 78, so I could do 37 times 78 over here. 7 times 8 is 56, regroup my 5. 8 times 3 is 24, plus 5 is 29. Pen to 0. 7 times 7 is 49. 7 times 3 is 21, plus 4 would be 25. 6 plus 0 is 6, 9 plus 9 is 18. 5 plus 2 is 7, plus 1 is 8. 2 plus nothing is 2. So I would get 2,886, and then 1,000 times 100 would be 100,000. So it would be 2,886 100,000ths, okay? But, so that's just one way you could do it. And if you multiplied something like this and you just use fractions, I am definitely okay with that. But if you want to keep using the decimals, okay, if you like decimals, here's another way we could tackle this problem, okay? So I'm going to rewrite this up and down. So I'm going to do 0 and 37 thousandths times 0 and 78 hundredths. And the first step in strategy 2 says multiply both factors by a power of 10 to make them whole numbers. Keep track of the powers of 10 or the total number of places the decimal shifted. So I need to try to make 37 thousandths. I need to multiply it by a power of 10 to get it to a whole number. So I can multiply 37 thousandths by 10 to the third power to get 37. Let me show you. 1, 2, 3. My decimal point has to move 3 places to the right to get 37. For 78 hundredths, I need to multiply that by 10 to the second power, and that would equal 78. 1, 2. My decimal point, I moved 2 places to the right. So it moved 3 places to the right here because I had to multiply by 10 to the third power, and it moved 2 places to the right because I had to multiply 10 by the second power. My next step, let me change my colors here. I had some trouble. My next step is to simply multiply the whole numbers that I created. So now I have 37 times 78, and I already did 37 times 78 over here. So I already know the answer to that. 37 times 78 is 2,886, okay? I'm going to get rid of my comma here. But we really weren't multiplying 37 times 78. Remember, original problem was 37 thousandths times 78 hundredths. So the last thing to do is I need to undo the multiplications of 10. So the opposite of multiplying is dividing. So I need to take that product that I have and divide it by, well, I moved my decimal point 3 places to the right here and 2 places to the right here. So I moved it a total of 5 times. 2 and 3, 5 times. So I'm going to divide it by 10 to the 5th power. So if here's my decimal point, I need to move that to the left 5 times. 1, 2, 3, 4, 5. And then there's my answer. So rewrite my number. And I believe it or not, I can say this number, okay? Here's my tenths. Here's my hundredths, here's my thousandths, here's my 10,000ths, here's my 100,000ths. So my answer is 0 and 2,886 100,000ths, which is exactly what I got here. So it totally makes sense. So whether you decide to move the decimal point or make the problem into fractions like I did up here, it doesn't matter. It's the same thing, just written at one as a fraction and one as a decimal. Let me show you strategy 2 again, because we can actually use strategy 2 using numbers like this, 43 1/10 times 5 6/10. If you have something like this, I could make an estimate with this, so I encourage you to still do something like that. So 43 1/10, I'm just going to make a quick estimate up here. It's 40 times 5 6/10, which is 6. So 40 times 6 is 240. Okay, that was quick and easy. Okay, 6 times 4 is 24, append a 0. Now strategy 2. So let's continue with strategy 2. Strategy 2 says first to multiply both factors by a power of 10 to make them whole numbers. Keep track of the powers of 10 or the total number of places the decimal point is shifted. Well, to get 43 1/10 a whole number, I need to multiply it by 10 to the first power. Let me rewrite these vertically so you can see that a little better. So 43 1/10 times 5 6/10. Okay, making sure my decimals are lined up here. So I can multiply 43 1/10 times 10 to the first power. That decimal needs to move one place to the right to get a whole number. So times 10 to the first power, and that would equal 431. Okay, and then 5 6/10. Again, I also need to just multiply that by 10 to the first power. Just needs to move one place to the right to get a whole number. So times 10 to the first power, and that equals 56. And now my second step is to multiply the whole numbers. All right, so I'm going to use that purple for that. So I'm going to do 431 times 56. 6 times 1 is 6. 6 times 3 is 18. 6 times 4 is 24. Hold on, I made a mistake here. Let me redo this, okay? 6 times 1 is 6. 6 times 3 is 18. I forgot to regroup my 1 over here. 6 times 4 is 24, plus 1 is 25. Cross that out. Append a 0 before I start multiplying my tens digit. So now I can multiply that 5 by each digit. 5 times 1 is 5. 5 times 3 is 15. Regroup my 1 up here. 5 times 4 is 20, plus 1 is 21. Now I add them up. 6 plus 0 is 6. 8 plus 5 is 13. 5 plus 5 is 10, plus 1 is 11. Group that 1 over here. 2 plus 1 is 3, plus 1 is 4. And 2 plus 0 is 2. Okay? So now I need to undo. So now I'm on my last step after I multiply. Because remember, that's not really my product. So I'm really multiplying 43 1/10 times 5 6/10. So I need to undo the multiplication by powers of 10. So remember, the opposite of multiplication is division. So I need to divide it by 10 to the, excuse me, but 10 to the second power, okay? Because I moved it one place to the right here and one place to the right here. So I need to undo it by 10 to the second power. So if this is my decimal, I need to move over 2 times. 1, 2. And my answer is 241 36/100. And because I was able to make an estimate for this one, I could see, hey, that's awfully close. So this answer makes sense. So the biggest thing, actually, when you multiply decimals, is to make sure that you're doing the arithmetic right when you're actually multiplying. It's easy to make mistakes. For example, on this one, I almost made a mistake, but I was able to catch myself. So just be careful that you're attending to precision when you're multiplying decimals, all right? I hope this video helps. You can go back to it any time if you forget some of the steps to help you multiply decimals by decimals.